This video is about the multiple comparisons that can be done with a within subjects design. Within subjects designs are designs where each participant is tested under multiple conditions. So each level of your independent variable, where your independent variable is what establishes the groups that are being compared when you're doing mean comparisons in ANOVA. But within subjects designs is that every single participant is in every single level of that independent variable. And this is what the equation looks like for this type of model. Very similar to the between subjects designs, but slightly different based on the variances that are being used. These within subjects designs are also called correlated error models, but the one that you would most likely hear is repeated measures designs, or this is can also sometimes be called longitudinal ANOVA. So this goes by several different names. But regardless of the name, the biggest point is that every participant is in every level of your independent variables. So each participant is in each group. So now your ANOVA is more like a paired sample t-test than an independent sample t-test. So for the between subjects designs, you have independent groups where the participants in each group are only in one group. Whereas with now the within subjects design, it's like a paired sample t-test where we use paired sample t-test for like a pre-test, post-test comparison. And this is where every participant is in both groups. It's both in the pretest and in the post-test. But now we have 3 or more of these groups to be able to do this within subjects designs ANOVA. And so the subjects are providing multiple values for the dependent variable. And so for each level of the independent variable, each participant will have a value for the dependent variable. So the means of the dependent variable are still what's being compared across the groups, just as in any other ANOVA design. But now you have each participant is at every level of the independent variable. And so this repetition can be over time, and most often we see it over time. So it's 3 or more time points where each participant has a value of the dependent variable at each of those time points, but it could also be over treatments where it's like a leveling or a stacking of treatments, or it could be something where it's the increase of sessions, so the number of sessions, but you are measuring the dependent variable at each session. So then session 1 dependent variable value could be compared to session 3 dependent value and look and see if there's mean differences across all these different treatment levels. So just like with a between subjects design, you could have both planned and post-hoc comparisons that you use for a within subjects design. But the planned comparisons are actually always better because you'd want to have those planned out to ensure that you have enough degrees of freedom as well as enough power to be able to really trust those comparisons, just the same as with between subjects. But when you have planned comparisons, you don't have to worry as much about sphericity and the assumption of sphericity, where it's not a problem since a lot of times there's only these 2 levels in any comparison. And so you only have one covariance. And so when you're doing these comparisons, you usually are doing something where it's like the very first value to the very last, you're just doing any two levels at any one time. And so then that makes it a lot easier. And that helping with that sphericity also is what's going to help with your degrees of freedom and your power. Now, post hoc comparisons. If you're doing a post hoc comparison, what's happening now is you're comparing every single level of your independent variable to all other levels of your independent variable for all of your participants. And so you can only use fixed effects to be able to do this. You cannot use random. And it also is really using a lot of your degrees of freedom to be able to complete all of these comparisons when typically you would only be using one, maybe two of the comparisons to really interpret and to add to your results. So a lot of times post-hoc comparisons with the within subjects designs don't make a lot of sense to do. Plan comparisons, though, can be really helpful. If all of the comparisons or the contrasts that you're using are going to be pairwise, where you're only comparing two levels at a time, you can use paired sample t-tests for these comparisons. So you can run just multiple paired sample t-tests to be able to conduct your comparisons. But you cannot do complex contrast this way. You have to run your complex contrast as a repeated measures design. So essentially another within subjects design to be able to look at complex comparisons. So typically Capel's recommendation for within subjects contrast is to use a single sample t-test. So where you're just using a paired sample t-test to be able to do this comparison. And you simply can just run that calculation in SPSS or any statistical software you're using. The only problem with this is there's not a better error control system for when you're doing multiple comparisons. So remember, you have to be controlling for error as well as for your type 1 error as you are conducting these comparisons after completing your original within subjects ANOVA design. And so if you are going to do multiple comparisons, you will probably want to use a Bonferroni or some other correction procedure as part of your post hoc comparisons to be able to control for the type 1 error and be able to pay attention to the number of degrees of freedom that are being used.